Okay, the example that we were working on before we ran out of time, Cole had it factored correctly for us. And so we're going to take 6x squared minus 8x minus 4 and write it over its factors now, x minus 1, x minus 2, x plus 2. And then set that equal to, we'll break this up into its parts. X minus 1 plus b over x minus 2 plus c over x plus 2. And the task then becomes to figure out what a, b, and c are to make this basically break up the complex fraction into 3 smaller partial fractions. All right, so from here, if I multiply both sides by this denominator here, so by the x minus 1 times x minus 2 times x plus 2, I'm going to be left with just 6x squared minus 8x minus 4 on the left, and on the right, the x minus 1's cancel, so I have x minus 2 times x plus 2 times a plus x minus 1 times x plus 2 times b plus x minus 1 times x minus 2 times c. And continuing down here, now you get to pick your x values, because our goal again is to solve for a, b, and c. You don't have to lock into one x value for all these. So I think a good natural one is let's let x equal 2. And so if I do that, if I plug 2 into the 6x squared, let me find a calculator here. So 6 times 2 squared minus 8 times 2 minus 4, that gives me 4, so 4 on the left. And then the 2 in here becomes 0, so 0a. The 2 in here becomes, let's see, 1 times 4, which would be 4b. And when you plug the 2 over here into the c, it becomes 0c. So the a and the c go away, and I just am left with 4 equals 4b. And so if I divide both sides by 4, I'm left with b equals 1. That's the one I found first. To figure out, probably the next thing I'm going to plug in is, let's go ahead and plug in x equals 1. So if x equals 1, then the top is 6 minus 8 minus 4, top is negative 6, or the left side, excuse me, is negative 6. The right side, let's see, I'm going to get negative 1 times 3, I'm going to get negative 3a plus 0b plus 0c, because the 1 in here and in here basically makes it go away. So if I divide this by negative 3 and this by negative 3, I'm left with a equals positive 2. And now the only one left to figure out is c, and to do that, we'll let x equal negative 2. So negative 6 times negative 2 squared minus 8 times negative 2 minus 4. This equals 36 on the left. And again, I'm just plugging, to figure out the left side, I just plug into the 6x squared minus 8x minus 4. And let's see, the negative 2 will make it 0a and 0b. And over here, I'm getting negative 3 times negative 4. Yeah, negative 2 minus 1 is negative 3. Negative 2 minus 2 is negative 4. So I get negative 12c. Set that equal to the 36. and divide by -12. So c is going to equal -3. All right, so that's the algebra portion here, and we've got a little bit more adjusting to do, but I think we'll be okay. Taking these values and plugging them in. To our original. So I gotta scroll up and look at the original here. And actually, if I can, group that. So I'm going to rewrite this integral as the integral of, and I got to look back and see what a was. I don't know why it's scrolling so slow. I apologize for this. A is 2. So 2 over x minus 1 dx plus the b was x minus 2, and I believe b was I don't know what b was. I better go back and look. B was 1. And then the c portion was -3 over x plus 2. And I gotta squeeze a dx in there somewhere. Make sure I got these right. So we got 1 for b, 2 for a, and -3 for c. So, okay. And now the actual calc is pretty comfortable because it'll be 2 times the natural log of the absolute value of x minus 1 plus the natural log of the absolute value of x minus 2, and then I'd say minus 3 times the natural log of x plus 2. And I didn't really have to do and all that's plus c. Didn't have to do a u substitution here because of the x to the first power, and there are no coefficients in front of it. So yeah, that's the last example that we're working on, and I'll try to put a few others on here for you.